So hello everyone, and today we'll be seeing one of the problem from Gigs for Gigs. The question is pretty simple. It says height of a binary tree. We are provided a binary tree, or let's say a root of a binary tree, and we are asked to find out what is the height of a binary tree. So how do we define the height of a binary tree? Height of a binary tree is number of nodes from the root till the end. And in this particular example, uh, we can consider that single root is considered as mm, tree of a height 0. So if I could write it somewhere to make things more clear, so if a tree comes in with only root, then height is 0, and if tree is null, then the height is -1. For rest of the cases, for like for what should I say, level 1, so if it is level 0, level 1, height is 1, and so on. So how did I computed this height? So I'm not talking about programmatical way. First figure it out, how can we compute height? So initially we have a tree which is in this fashion. I go ahead and check, hey, what do height which you have, and I'll add 1 of myself to it. So if I go ahead and check, it is 1, 2, 3. Since it's starting from 0, I'll just count it out like 0, 1, and 2. The rest of things are null, so I'm not going ahead and counting that. So the entire height is 2. Let's check this hypothesis here as well. So we have 0, 1, 2, and the height is 2. No, that's not the case. So 0, 1, 2, and 3 here, or 3 here, anyway, which works. And the entire height is 0, 1, 2, and 3. So the answer is 3. So how do we consider? So we consider it a maximum height of left or right, including the root. So the key point to note here is we need to have maximum height from left or right and include root. This way we get height of the tree below us, or this way we get height of the tree to which we have node as root. So considering 8 as the root of this tree, which contains 8, 5, and 11, the height is 0 and 1. So with this logic, we go ahead and we implement this one. So what I'll do is I'll just copy this one, I'll remove this and paste it. It's a plain English, and that's how the magic will begin. We'll convert this plain English into programming Java program. So we took if tree is null, then return -1. Okay, we'll do that. So if node, we are speaking about node over here, node is equal to null, then I do go ahead and let me zoom this a bit, return -1. Yeah, and next what do I say? Maximum height from left or right. So I'll just go ahead and say mat.max, which is maximum height from left, I'll say height from left and height from right. So my question is, we have a height function, we have a left node, we have right node. why not we go ahead and use this? So let's go ahead and compute the height of left, and in a similar way compute the height of right. Nothing fancy whatsoever, I have written it earlier, that's what I'm doing it. And then I'm saying same maximum height from left and right and include the root. So how do I include the root? So root itself is 1 plus, and in this way we get height of a tree below us. So return this. If we get this height, then why don't I return this? So let's compile this one and check for the sample test cases. It has ran successfully, and check for the rest of all the test cases. See, this problem where we are calling the same function is called as recursion, and we have solved this problem with recursion. As you can see, it has passed rest of all the test cases. Recursion problems are pretty notorious to think in the first sight because these are not meant to think with a naive brain, but once you crack the logic, you crack the pattern, it is super simple to implement, and the code takes not much than, like in this case, 1 2 3 lines of code. Condition if, return statement over here, and the third line, return statement of this line. So the code is super simple, but the only problem is to get to the approach. And you can practice this kind of solution by clicking the video on your right, and I'll see you in the next recursion problem. Thank you.